We want to look at differentiation today, and we are looking at it at a very basic level. Now, when we say very basic level, we are looking at it at we're looking at the power derivative of power function. Now, in differentiation, we'll take power function. We have y as a function of m x raised to power n. Now, in this situation here, y is a power function. The derivative of this, which we call dy dx or f prime of x, is simply obtained by we multiply the power, is n, by the function mx, but the new power now will be the old power minus 1. So that gives us the derivative of this power function. It is as simple as that. Whenever we have a power function of this form, then the derivative, which is called dy dx, will be the power, which is n, times the function, that's n times, we multiply the function by the power, that's n times mx raised to power n minus 1. We must always subtract 1 from the whole power to get new power. So that is the derivative of a power function. Now, to apply this formula or this rule, we're going to consider like 3 or 4 examples. Let's look at example 1. If we have y to be equal to x squared, y to be equal to x squared. In this case, the power of x is 2 and the coefficient is 1. So we say dy dx now will simply be equal to the power, which is 2, times the function itself, raised to power 2 minus 1. And that gives us 2x raised to power 1, which is what? 2x. So at any time when we have x squared, the derivative is going to be equal to 2x. We simply applied the formula to solve that. Another case is we have y equals to x. It is obvious here that the power of x is 1. So to differentiate, we have the y dx. Y dx now will be equal to the power, which is 1, now times function itself is to power 1 minus 1. So that gives us 1x raised to power 0. Whenever we raise any variable to 0, we have 1. So that is 1 times 1. And that gives us 1. So whenever y is equal to x, then the y dx or derivative of the function will be equal to 1. So that is simply applying the normal power function rule for differentiating a power function. Now, let's take another example. That's example 3. If we have y equals to 3x squared, the rule still applies. The rule still applies. Our dy dx now, dy dx will be equal to the power will come down to multiply the function. Now the function will reduce by 1. That's the power of the function will reduce by 1. That gives us 2 times 3, which is what? 6. X raised to power 2 minus 1 is what? 1. So we have 6x raised to power 1, or we call it 6x. So when we differentiate y equals to 3x squared, we have 6x. Now let's take another example. Example 4. If we have y to be equals to cube root of x squared. To differentiate this type of function, we need a little knowledge of indices. Now we have to rewrite it as y equals to x raised to power 2 over 3. That means we have changed the function to indices form. We have to index form. So we have x raised to power 2 over 3 now, and that can be easily differentiated as the y, the x will be equal to 2 over 3 times the power, multiplying the function now, raised to power 2 over 3 minus 1. We are still applying the rule. Now, from simple mathematics, that gives us 2 over 3 x is power. When we subtract 1 from 2 over 3 from simple fraction, we're going to have minus 1 over 3. Now, so that is what we have. Now, this is an answer, but we may not see this in multiple choice questions, so we have to still go ahead and further simplify this answer. So we're going to have 2 over 3 times 1 over x raised to 1 over 3. That is law of indices applied. And we can finally simplify it as 2 over 3 cube roots of x. So that is our final answer. So we have 2 over 3 times cube root of x. So that is it. We applied some laws of indices here to be able to arrive at the final answer. Otherwise, we would have just had the form this nature. So we can have it in this way. That's a better form that shows that we know what we are doing. Finally, we can have a question in the form of y, a function of y equals to 2 over x squared. To differentiate this, we can first rewrite this as y equals to 2x raised to power minus 2. That is from indices. Now, applying the normal power function rule, we have divided x to be equal to minus 2 times the function 2x minus 2. Now, subtracting 1 again from the original power of x. So we arrive at minus 2 times 2 is minus 4. We have x is to power minus 3. So that is our final answer. But to be more professional, we went ahead and say minus 4 over x cubed. That is following the law of indices. So that's our final answer. So divided x is minus 4 over x cubed. So thank you very much. I hope you enjoyed this video. Make sure you go over it once again to have a clearer understanding. I wish you all the best. Thank you.